Hey Algebra 2. So what I'm going to do is review over the second lesson, which covered the graphing of an absolute value function, identifying the transformations of an absolute value function, and how you can write the equation given basically a vertex and a point on the graph of an absolute value function. So the first thing that I want to actually graph is just the absolute value of x plus 4 plus 1. So the first thing we were doing in class is identifying the transformations. So what I had you guys focus on was looking for a reflection in a vertical stretch and shrink first. The number that's being multiplied by the absolute value of x plus 4 that would represent the a value in this case is 1. So it doesn't show us there's a reflection, and because it's 1 I don't have to worry about a stretch or a shrink. So what I'm going to do is just move on to my horizontal translation. So that comes from the number that's being added or subtracted to or from the x. So in our case it's plus 4. So since it's positive 4, it's actually going to go to the left 4 units. Okay, so we got left 4 units, and then the vertical translation comes from this plus 1 outside the absolute value symbols. And so this plus 1, it's actually going to go up 1 unit. Okay, so this is what we're going to do for this one. So it's a little different. I'm going to take the points that make up the parent function for the absolute value function, which are negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Plot those puppies on this coordinate grid. So there you have that. And what we're going to do is just shift the parent function graph using the transformation. So I'm just going to shift it to the left 4 and up 1. So I'll put that graph on here. And you can see that red graph reflects that shift. So like if I just use 0, 0 as an example, you go to the left 4 units, which would bring you to negative 4, and up 1, which would bring you to positive 1. And that actually brings us to our vertex, which represents a minima in this case. So you were asked if it's a maximum or minimum. It is a minima, and it's at negative 4, 1. Another thing that you were asked would be for the domain. In this case, it's the absolute value function, so it's all reals for the domain. And then the range, my y value actually starts at positive 1. So positive 1 right here, and goes on forever and ever. So we're going to say from 1 to infinity. And that pretty much concludes a good example of an absolute value function that doesn't have a reflection, vertical stretch, or shrink.